So the problem that we're interested in is pretty obvious when you stare at it in the face, which is that in order to achieve scale, many of these social media platforms have started relying more and more heavily on artificial intelligence to help identify what they would describe as problematic, toxic behaviors. These might range from aggressive or harassing comments to spreading disinformation. This is where it's worth sort of understanding a little bit about how these AI systems get built to understand what we need to do better. So AI generally sucks in a ton of data. This is referred to as training data, and makes sense of it to try and make predictions that would be the same as the training data that it was given. And where does that training data come from? Well, in many cases, there's a bunch of people who were paid to look at content and say, that's harassment, that's toxic, that's not, that's toxic, that's toxic, that's toxic. And to make sure you're gathering a wide variety of perspectives, you ask a bunch of people, but now you have a bunch of different answers. And so what they tend to do is take a majority vote and say, well, if most people say this is toxic, we're going to view it as toxic. And this works really well when you're training an AI system to differentiate dogs and cats, but less well when you're trying to decide whether someone has crossed the line and started harassing. And the reason for this is that often minoritized communities are going to draw the line of what's harassment, for example, differently than someone who maybe looks like me and has been historically subjected to less of that kind of behavior. But because they're minoritized communities, they're usually smaller, and when you just take a majority vote, guess whose voice is getting erased? Minority groups. And as a result, the AIs aren't representing their perspectives. So we know that AI systems in these social contexts are erasing minority views. What do we do about it? So what we actually need to start to do is train the AI to essentially be able to take on the points of view of a bunch of different people. So the high-level approach that we're taking is drawn after this metaphor of a jury. Imagine if instead of an AI simply saying this or that is the answer, the metaphor is that the AI is trying to replicate a jury of people who may have different opinions, and those opinions are then aggregated into a result. So what this makes us do is it makes us make explicit who's in this jury. How many people are represented in the jury from various different groups, different groups you might care about, or intersectional identities. So instead of simply saying, this is the correct answer, we say, well, a quarter of the jury represents people who look and feel this way, a quarter of the jury are from this group, et cetera, et cetera. At the end of the day, what the AI is going to do is select a bunch of jurors who represent these various groups at random, and then we'll predict what each of those individuals will say, and then we essentially get the jury result. Turns out this is easy to say, hard to get to work, but Mitchell Gordon, who's my PhD student, has done a ton of work in this space to really make it happen.
So we start by creating juror sheets. This is indicating the kind of jurors that you want. We can select multiple different constraints. So in this case, we're just going to make 2 juror sheets. One juror sheet where we're saying we want jurors who are politically conservative, one juror sheet where we're saying we want jurors who are politically liberal. We now compose our jury. So we have 12 juror slots here. And in each of these slots, we simply assign each juror slot to a particular juror sheet. So in this case, this corresponds to juror sheet 0, which is, again, politically conservative. In this case, we're saying that we want these first 6 jurors to be politically conservative, because that's what's in juror sheet 0, and these other 6 jurors to be politically liberal, and that's what's in juror sheet 1. And what happens is, when we perform our computation, we assign each of these juror slots a random juror that meets these constraints. So we assign them a random actual juror in our data set who is politically conservative in this case or politically liberal in this case. What happens then is you can enter a comment that you want to analyze and see some results based off of what different jurors think. So in this case, what we can see here is that for this particular comment, politically conservative jurors tend to think that it's a little bit less toxic than politically liberal jurors. And this scale here is 0 is not toxic at all, 4 is very toxic. What these bold lines indicate here, they correspond to actual jurors, the people that we actually filled these slots with. And then these more opaque lines, these each correspond to predictions for other people from this juror sheet in our data set, just to give you some context of where your particular jurors that we assign to your jury fall within the larger possible set. You can see there's a lot of variation. Basically, within, say, politically conservatives, there's tons of different opinions, all the way from 0 to almost 4. So this is not some sort of universal opinion that conservatives or liberals have. So in this case, we're saying that it's this comment, shut up and get out of here, is relatively toxic. This value is a result of taking the mean value of all these 12 different bold lines. And now you as a user can then go and change your jury composition. You can change your juror sheets. You can get an understanding of, if you had a different jury, what would they think about this comment? And you can imagine using other comments that you might find differences. This is a sort of example comment, because we don't want to show anything too dramatic on camera here, but you can imagine entering all kinds of awful comments, and depending upon what makes the comment awful, finding that different jurors have different opinions about them.
I think that the metaphor of the jury was pretty clear for us from the very beginning, if not the very beginning, near the very beginning. And while there have been twists and turns in how exactly we instantiate that, I think that's become a sort of North Star that we've tried to hold on to. And I think a lot of the twists and turns have been about how we mesh that with the technical underpinnings of machine learning. Finding moments where, oh my gosh, this model isn't training. There was a long period where we were really going around in circles, including with top experts in machine learning, about why this wasn't working the way that we wanted it to. Those swamps can be very demotivating, but sometimes that's what we have to push through. As long as we're learning something as we're cutting through the swamp, then we have a chance of getting out of it. We only fail when we stop learning something.